Hey everyone, welcome back to TextConnect. In this video, we will be discussing about the motions of weaving. But before that, are you all well aware about the process of fabric manufacturing? So if there are any doubts, then I highly recommend you to watch the short video which discusses the overview of fabric manufacturing. Now let us come back to weaving. Weaving is one of the processes for fabric manufacturing. I want you all to answer me, what is weaving? Just pause the video for a while and type it down in the comments. So that was it. I hope you all got that right. Weaving is the interlacement of warp and weft yarns to produce a fabric. Now the next question is, how do the yarns get converted into a fabric? So the machine on which weaving is done is a loom. And there are certain motions of weaving which function together on the loom to produce a fabric. So in this video, we will be discussing these motions of weaving. Now first let us understand the components of a loom and the passage of a warp yarn to the fabric on the loom. So on your screen is the diagram of the cross section of a loom. The input side of the loom where we feed the warp yarns is known as the back side of the loom, and the front side where the fabric is delivered is known as the front side of the loom. Now if we look at the components of the loom, on the back side is the weaver's beam. On this beam the warp sheet is wound. The warp then leaves the beam and it passes over the backrest. So this backrest is placed just above the weaver's beam and it guides and supports the warp yarns. And it then passes through the lees rods which separates the warp sheet into two layers. Now next, the yarn passes through a metal device called the drop wires. This device detects any faults or breaks in the warp yarns. The warp then passes through the heel shafts which controls the movement of the warp ends. Now the ends then pass through the reed. This is like a comb-like structure, so it plays a dual role. So one of them is it pushes the newly inserted pick into the fabric towards the fell of the fabric. So what is the fell of the fabric? It is the point on the loom where the yarn becomes the cloth. So this is the when the last pick is beaten up into the cloth. So this boundary is known as the fell of the fabric. And the other role of the reed is to maintain the position of the warp yarns. So now the fabric is ready and it passes over the front rest. So this front rest is on the front side of the loom above the cloth roller, and it guides the cloth onto the take-up roller. So the front rest, it maintains the tension and ensures that the fabric is in line with the warp sheet in the proper horizontal position. Now we just saw the passage of a loom. So for weaving process, the loom undergoes a cycle, and this cycle consists of basic motions. So the weaving motions can be classified as primary motions, secondary motions and auxiliary motions. The primary motions are the ones that are primary or are necessary for the working of the loom, and without them the manufacturing will not be possible. So there are three primary motions: shedding, picking and beat up. Now the first primary motion is shedding. So we saw on the loom that the warp sheet is separated and then they are lifted. So this will create a passage in the warp sheet. Now one group of threads are lifted up and the other are lowered. This process is known as shedding. This creates a clear passage for the weft yarn to pass. Now in this image we can see that the yarns in the red are lifted upwards and the ones in the green, they are moved downwards or they stay in the down position. So this is known as shed formation. The yarns are moved by the heel shaft or also known as the heel frame. So the heel frame has heel wires through which the warp yarns pass. Now the second primary motion is picking. First of all, the weft yarn is also known as a pick. So picking is the process in which the weft yarn is inserted into the shed. This process can be shuttle or shuttleless. Now shuttle is a wooden structure which carries the pick across the shed. And in shuttleless process, the weft carrier could be projectile, rapier or jets like air or water jet. Now we already have videos about the shuttleless weaving process, so to know more you can check them out. Now we move on to the third primary motion, which is the beat up motion. So once the pick is inserted, the reed pushes it to the point of the last pick, that is the fell of the cloth. and here the cloth is formed. So this process is known as the beat up motion. So one beat up is done after every pick. So now we are aware of the three primary motions that are shedding, picking and beat up. Now let us move on to secondary motion. Now we understood the insertion of a pick and how is it done. But also we'll have to consider about the input and output material. So for continuous production, the secondary motions come into play. So these are the let off and the take up motion. So the take up motion. Now the process of winding the newly formed fabric on the cloth roller is the take up motion. And talking about the let off motion. So as the cloth will be rolled, the warp tension will increase. So in order to maintain constant tension, the warp ends will have to be released from the weaver's beam. And to avoid any kind of yarn breakages and to ensure constant input material. So let off is the process where the weaver's beam is unwound to let the warp yarn in at a constant rate. So to maintain a continuity in production, it is important that both the let off and the take up motion are carried out at proper intervals to maintain a balance. Because if either of the process doesn't happen, the tension will be affected and it will lead to breakages and damages. So now we'll quickly watch an animation to understand the primary and secondary motions. So we can observe the separation of the warp yarns to form a shed, and we can see the shedding process. Now as soon as the shed is formed, the weft is inserted and the picking takes place. And after weft insertion, the beat up is done. Also simultaneously, the let off and take up motions are also working to ensure regular input and constant output and maintaining the overall tension. So for continuous production, the primary and secondary motions work together accordingly. Now let us discuss about the auxiliary motions. So these motions are basically for the improvement of quality and production. They enhance the working and prevent damages and produce less defects. So for instance, the warp breaks or a pick is missing. Then a signal has to be made for the loom to stop so that further damage is controlled. So auxiliary motions come into action in this situation. Now that we'll discuss the types of auxiliary motions. So the first one is warp stop motion. So the warp stop motion stops the loom when a warp thread breaks or it excessively loosens. Now if the warp yarn breaks, the metal device, that is the drop wires, it falls and it completes an electrical circuit which stops the loom. The next is the weft stop motion. So when the weft thread breaks or it exhausts, so to prevent any kind of missing picks in the fabric, the weft stop motion stops the loom. Now in case the loom doesn't stop, there won't be any fabric formed. It will just be long threads of warp if the picks are missing. The next auxiliary motion is the warp protector motion. So consider if the shuttle gets trapped in the shed or the weft carrier is not able to reach to the other side of the loom and the reed continues to beat up. So then this situation will cause heavy damage to the shuttle, to the reed wires, and will also cause multiple warp threads to break. So to protect from this damage, the warp protector motion comes into action. Now, if the shuttle doesn't reach the shuttle box in time, it senses the missing shuttle and initiates the stopping of loom. The last one is the temples. So temples hold the cloth firmly at the same width as that of the warp, and it prevents the fabric from contraction. So this ensures the fabric doesn't contract and undergoes weaving contraction, and the width of the fabric is constant and is maintained throughout. So this was it from my side. I hope this was easy to understand. If you like this video, then do hit the like button and let us know in the comments below if you have any queries. Also share this with all your textile friends. You can connect with us on Instagram, LinkedIn and Facebook. Or if you have any queries, you can drop us an email. We'll be back with another video super soon. Until then, keep learning and keep watching TextConnect, our learning center for textile.